Hello folks. Let's see, this time around I want to start getting into control structures. So we're going to start this off talking about blocks. So the idea is any group of statements is treated as a block. So any place where you can take a lump of statements and essentially treat them as a single unit somehow. So that's where I want to go today. The idea is that most languages will provide some kind of support that's hopefully consistent. Bash is an exception there. Hopefully consistent about how you denote the beginning and end of a block. So you'll either have the curly brackets like in C to indicate where it starts and where it stops, or you'll have indentation levels like in Python, or you'll have begin and end keywords, but something to tell you where it starts and where it stops. And usually the idea is that most of the rules are the same around all the different places you can use blocks. So you think of the block of statements inside a function, or the block of statements in an if statement, or the block of statements in a while loop. The idea is the block part is all pretty consistent. The scoping rules are similar. The syntax is similar. Again, there are languages where they use different syntax and different rules for all the different places you have blocks, but it is something that we want to go through and talk about. We'll talk about, again, scoping rules. We'll talk about whether blocks can return a value somehow. We'll talk about entry and exit points to blocks as we go through this. So again, typically you need some kind of delimiters to say where this starts and where it stops. Usually one of the most recognizable syntax aspects. We're all used to the idea of begins and ends, or open curly brackets, close curly brackets, or indentation levels. It is something that is pretty pervasive in whatever language you're using. One of the things that you do need to consider is whether or not a block can be dumped anywhere. Like, can I just, at any point in my program where a statement would be valid, can I stick in an open curly bracket, a bunch of statements, and a closed curly bracket? And will that little group of statements have its own scope and its own rules somehow? Will there be something unique about that particular statement? So you can do that kind of thing in C, for instance, where you go through and just say, okay, well, let's have a little block of statements with a little local scope in it. One of the things that you'll find is that in some languages, the blocks themselves are not, you can't explicitly create a brand new block anywhere, but they're implicitly part of most of the other control structures, right? You have to have a curly bracket and a bunch of statements and a closed curly bracket after the if and condition, or after the while and condition, or whatever the language syntax might be. One of the questions that we do want to go through and talk about is whether or not the block can be used within an expression. Can your block return a value that can be used as in the midst of some expression, right? We've seen this idea in Lisp where we actually have a block statement or a block function, but similar ideas can be applied in other languages. Again, I've mentioned scope a couple of times now. Does each block have its own local scope? And if so, are we following the rules the same way as for the rest of the language? Are we using lexical scoping or dynamic scoping? Is there a way to refer to different layers of scope? So if I have a block inside a block inside a block inside a block, and each of them declare a variable x, is there a way to get at, the local x or the innermost x, and then the one in the layer just outside that, and the one in the layer just outside that? Or is it simply the case that if I refer to x, I'm getting the local one and that's it? All right, or something like C++, for instance, where you can say, well, I can get at my local one, or I can put 2 colons before the identifier and get at a global version of the same variable, but we don't really have a mechanism for referring to the ones that are layered in between. Again, I've mentioned consistency once or twice here. Are the rules that you're using consistent across all the different types of block? If I just have a random little block of statements somewhere inside a bigger block, do the rules apply the same there as they do as a block for a switch statement? or as a block for a for loop, or a block for an if statement, or a block for a function definition. Right? It's entirely possible that the scoping rules for a little tiny local block are different than the scoping rules for the block of statements in a function definition. Yeah, all things that you want to consider, all the things that you will need to address if you're ever working at the compiler level or debugger level or working on an IDE someplace, or going through and defining your own language for that matter. One of the things that we're used to looking at in terms of blocks with respect to loops is the idea of, can we get out of a block early? Usually the idea is you enter the block at the top, the first statement, and you leave the block at the last one. But different control structures might provide a way to leave early. So things like the break statement in C or C++, where you can say, okay, well, I want to get out of this current block now. Or things like a return statement, right, for leaving a function early. You could have multiple different return statements, and the first one you happen to run is the one that takes you out. Or for that matter, that might work just fine from within your block as well, right? Return from block. Now, if you do have that idea, if you've got the notion that you can leave blocks early, do you want some way to specify that regardless of all the different ways that I leave this block, there's a couple of actions that I want to take place at the very end regardless? So maybe you've got a loop where you do a bunch of things to set it up, a bunch of initialization, and then you've got the body of the loop that you run through however many times, and then you've got a little block of code that you want to make sure runs to clean things up no matter how you left the loop, no matter which way you got out, whether you ran through to the end or whether you hit one of the break statements. So this idea of having some kind of last chunk or final chunk or finally chunk, some chunk of statements where there's a syntax with your block that says, here's a chunk of things that are part of this block that have to be run when I leave the block, no matter how I leave it. So, other things to consider. Now, if we've got multiple ways to leave a block, is it possible to have multiple ways to enter a block? We're all used to the idea of, if I hit an if statement, I come in at the top, I check the condition, and I start at either the if or the else section. Or if it's a loop, I start at the loop, maybe I check the condition, and either I go into the loop starting at the first statement, or I skip the loop entirely. But no matter what, you've got that one starting point that you're interested in. If we can have multiple exit points, is it possible that somehow, under some conditions, we could jump to the middle of a loop, for instance, and pick up from there, and see what happens from there? So if that's the case, then you've got all sorts of other weird and wonderful things to think about. If you've got some kind of variable declarations and initialization that take place at the beginning of the loop, and I skip past those, what happens? What does the compiler do? Right? Presumably the compiler sticks in definitions for, or sticks in memory allocations on the stack for things like local variables. So maybe the compiler goes through, has that space created anyways, maybe has it initialized somehow, maybe it doesn't initialize, it just leaves whatever random values are sitting in memory. And when you skip the definition portion of variables, of local variables in a block, in a loop for instance, then maybe it just picks up at wherever you are in the middle of the loop and proceeds from there, using whatever values happen to be sitting there in memory. So this is one of the things that I wanted to take a look at in terms of C, just to do a little bit of experimentation. So let's see what we can do here. And yep, minor technical difficulty here. We'll just add there we are. Okay, so what I want to do is to go through, and again, we'll take a look at a little chunk of C code. So this time it's this do-it-yourself control. So let's have a look at that. And in here, I want to go through and take a look at, that's not the one I wanted. That's one I wanted to take a look at a little bit later. It's the switch that I wanted to look at. So you got a little preview of stuff we'll be looking at later with loops. So with the jumping into the middle of a loop idea, the multiple entry points, what we're going to do here is kind of weird. We've got, if you look over here, we've got a while loop. Ignore the case statements over on the side there for the moment. We've got this just regular old while loop that says, well, x is less than 3, you know, print message about x, and there's a variable w, variable x. While x is less than 3, we'll print w and x, decrement w, increment x, print them both again, print a message that says we're at the bottom of the loop, and that's pretty much the end of the loop. So we're just going to go through this a few times. But what we've added on the outside here is this switch statement. This switch statement with an entry variable, and that's going to jump us to one of these different labels. So if entry is 0, for instance, then the switch statement will drop us here. And remember, with case statements, we don't try and leave the switch unless there's a break statement, and there's no break statements in here. So this will jump us to a certain point, and we'll just pick up and run the loop from there. So if I enter 0 as my entry point, I'll just run it from here. If I have 1 as my entry value, then what's going to happen is I'm immediately going to jump in here, skip this top test, and just immediately start running the loop from here. And when I get to the bottom, it'll pick up and run the loop normally. Or similarly, if my entry value is 2, then I'll jump over the first chunk of the while loop, right? I'll skip the condition test, I'll skip the printf, and I'll just pick up here, decrement w, increment x, and then resume running the loop as normal. And the same idea for these others. If it's case 3, I'll skip those 2 things the first time through and pick up running the loop normally. If it's 4, and I'll skip everything except that last printf and run normally. And if it's anything other than those 5 values, then we'll skip the loop entirely and pick up down here. So if you want to play with switch statements in C++, essentially they're a glorified way of creating labels and a bunch of goto statements where it checks the entry value, or checks your variable here, your value, your expression value here, and jumps you directly to one of these different cases that you've got. So it just implements them as a label, an if statement, you know, if value equals this, go to this spot, and then it just picks up running normally. So this is one way in C or C++ that if you really want to, you can create multiple entry points in the loop, where as far as the loop is concerned, you don't really know which one of these things got you in there, whether you picked up at the beginning, whether you picked up in the middle, or whether you skipped it entirely. So just to give you a quick look at that, let's just make sure we're up to date, and let's try our switch here. So we get to pick an entry point, and if you recall, 0 was the one that let us run the whole loop normally. So we go through and we see the loop going through 3 different passes. And if we try something else, let's try 3 for instance, then we should skip a chunk of that first pass. So in this case, right, we initially picked up that layer 1 was our top statement in the loop. We skipped that the first pass through. Now, because that first pass didn't do some of the updates to W and X, we wound up doing 3 passes after that anyways. So in this case, we actually got kind of 3.5 passes through the loop. Or again, if you go through, we try this one, that first pass, all we do is that last statement in the loop. And then we do 3 passes through the loop normally. Again, you get the idea. You can play around with this, see what it does under different circumstances. And in each case, we're skipping just a tiny chunk of the loop. Or in the case of 0, we're doing the entire loop. Or in the case of 5, we're skipping the entire loop. but it does give you a way to kind of emulate multiple entry points to a loop. It's not supported as part of the loop construct, it's actually a side effect of the way switches are implemented. All right, well, let me just get back to our main screen here. So, going through, I want you to think about blocks, how they're implemented, how this stuff actually works, what kind of an impact it has on the feel of the language, right? How frustrating is it if they use different syntax across all of the different kinds of structures, or if the scoping rules work differently, right? How much more difficult is it to learn, or how much easier is it to learn, depending on how consistent the implementation happens to be. Think about all the different ways this stuff might actually work behind the scenes. All right, we'll leave that there for now, and we'll pick up next time looking at selection and then looking at loops and eventually move on to subroutines.